Alrighty, welcome back. Hope everyone is well. Today we're going to be looking at, starting off chapter 17, we're looking at populations and samples. I guess the first thing you need to have an understanding of is the difference between a population and a sample. If we're talking about a population, it's going to cover everyone or everything within that particular category. So they've suggested here, if you were looking at the population, for example, of Year 12 students, that's all of the Year 12 students across Australia in this particular example. So it's everyone that's part of that category. That can often be a lot of people, and if you wanted to get data from the whole population, it's going to take a lot of time. And they've suggested some reasons for that there. On the other hand, it's often more desirable to get a subset, so a certain section from the population, and that's known as taking a sample, and that really is a lot easier to get that data rather than getting all the data from the whole population. Now, if you are going to go down the sample path, you need to make sure that they are being randomly chosen. And so it says here, a sample of size n is called a simple random sample if it is selected from the population in such a way that every subset of size n has an equal chance of being chosen as the sample. It says here, in particular, every member of the population must have an equal chance of being included in the sample. So you need to make sure that it's not being biased towards a certain area of that particular population. So here is example number one, which sort of gets us thinking about this. It says a researcher wishes to evaluate how well the local library is catering to the needs of the town's residents. It says to do this, she hands out a questionnaire to each person entering the library over the course of a week. It says, will this method result in a random sample? Okay, so what you need to consider here, if you're trying to get information from the population or a sample of the population regarding their library usage, it's probably, well, it isn't best to actually be getting the data from people that are already using the library. And they've suggested there that because they're already using the library, they're already probably happy with the service that's provided at the library because they're going there anyway. So they're suggesting it would be better to sample random people from the whole town, from the whole town's population, to actually find out who uses the library and who does not use the library. So this yellow box says, in order to make valid conclusions about a population from a sample, we would like the sample chosen to be representative of the population as a whole, and this means that all the different subgroups present in the population appear in the sample in similar proportions as they do in the population. So from here, often it's useful now to get these random samples from the population. And one of the ways in which we can randomly get these pieces of information, they've suggested, you could put all their names in a hat and randomly pull the names out of a hat. Obviously, that's going to take time to do all that, writing out the names on the piece of paper and pulling them out. So we can use our calculator and the random and generate random values using our calculator. So again, here we are on the Classpad. Here are a few different ways in which you can randomly generate numbers. First one is to find the actual random function. You go to the keyboard. Now it's in the catalog, so we go down here, we go to the catalog, random, so you can just sort of start typing R or find R here. This one is rand, yep. So you can run rand, and if you press execute on that, it'll generate a random number between 0 and 1. Yep. So that's useful between 0 and 1 if you're after a random value. Let's just run another random value between 0 and 1. Perfect. If you want to actually get a random value between certain numbers, so let's say you want a random number between 1 and 8, here's how you'd go about doing this. Again, you're using the random function. So you go to the catalog and you can get it. And then you're going to type in the values that you want it between. So I want a value between 1 and 8. So I'm going to do between 1, comma 8. And we'll close that function and execute it. This time we get a value, random value between 1 and 8. So that's useful if you want to get a random value between anything 1 and 100, 1 and 1,000, etc., etc. 1 and 100. Very easy to do. Perfect. Next, you might actually want to generate a list of random numbers. So what we can do in this case, again in the catalog, rather than just using the random function, you can go to random list. So if we run, get the random list, and we're going to say we want a random list of numbers of how many numbers you might want, 20 numbers. So you go random list 20, and so you want 20 of them, and to specify what values you want those 20 numbers to be between, what we're going to do is we're going to type in that'll just do random numbers between 0 and 1. 20 random numbers between 0 and 1. Cool. So you can see there you can use the right arrow on the keyboard, on the calculator, sorry, to get those. So that's 20 random numbers between 0 and 1. Again, you might want to specify what you want those random numbers to be between. So again, if you go back to this function, if you press a comma, you might want them between 1 and 10. So put the lower value, comma, the upper value. So we want to, let's do 8. Between 1 and 8, we want each of the numbers randomly generated between. Cool. So we've got now 20 numbers in the list, and they are all randomly, they all are between 1 and 8. So that's useful there. Cool. So you can scroll across and see them. Cool. So that's how you generate those random numbers on your calculator. Now, the reason I've suggested doing that is for the next example that's here. So again, whoops. Oh dear. You might want some values, or you might want to generate some random, select a random group. So here's some names of some people, and it says here, use a random number generator to select a group of 6 students from the following class. Cool. So what you would do is you would assign a number to each of them. And so what you can do here, you can see Denise is 1, Matt's 2, etc., etc. Each of those 20 students has a number from 1 to 20. Now to generate, or to get 6 of those students randomly, you would go to your calculator and you would get 6 of those numbers generated randomly between 1 and 20. So let's actually do this. So you want 6 random numbers, so a random list of 6, and you want them between 1 and 20. So between 1 and between 20. So running that, here we've got some random values. Now, what can happen is you might get a repeat of one of these values. So you can see here 1 and 1, so Denise is selected twice. If this happens, you can just generate another random number, and that would be the 6th person there. Yep. Once you've got these values, so there was 6 randoms there, I've got 5, and you could generate another one. That corresponds to the people that you would randomly choose. Yep, hopefully that's clear. The next thing is the chat about the sample proportion as a random variable. It says here, suppose that our population of interest is the class of students that we had from that example we just spoke about. And suppose that we, further that we want to particularly interested in the proportion of female students in that class. This is called the population proportion. And this, we generally write that out with a little p. Yep. It says the population proportion, p is constant for the particular population. And to work out p, the population proportion, it's the number in the population with that attribute. So in this particular case, it might have been female, divided by the population size. And so in the example that we had before with those randoms, there were 10 males, there were 10 females, so there was 20 in total. It says the proportion of female students in the class So there were 10 that were female out of the population size, which was 20. So half in that particular case was the population proportion were female. Further to that, where we had the sample chosen, if we consider the proportion of female students in the sample chosen, it says here the proportion of females in the sample may be calculated by dividing the number of females in the sample by the sample size. So in this case, it says the proportion of female students in the sample, there were 2 females, so Sue and also Georgia. 2 out of the 6, which is 1/3. That's obviously going to be different to the population proportion. It's the proportion based on the sample. So it's called the sample proportion. You'll notice that's different. It's got the P with the little hat over it. So if you see P with a hat, that's the sample proportion. Again, number in the sample with the attribute divided by the sample size. No surprises there. So things you need to know, summarizing it, says the population proportion is P. Sample proportion is P hat, is a sample statistic. Its value is not constant but varies from sample to sample. Last example, it says here use a random generator to select another group of 6 students from the same class and determine the proportion of females in the sample. So again, they number them 1 to 20. They've generated a random number, which we can do on a calculator, and it's pulled out these particular students. If you had to get the sample proportion, so P hat, which in this case was the number or proportion of females, Georgia, Teresa, Anne, and Sally and Denise, there's 5 females. Out of the sample chosen, there were 6. So P hat or sample proportion is 5/6. That's it for this particular chapter. Thanks for listening. Bye for now.